In this video, we're going to discuss the different sampling techniques that we can use to take a sample from a population. Before we do that, we need to distinguish between a population and a sample. In statistics, a population refers to every member within a particular group of interest. This could be the whole population of the world. It could be everybody that attends the same high school. It could be members of the same mosque or church. A sample is a subset of a population. A census is a survey conducted on every member of a population. There are 5 main methods used to sample a population. 1. Simple random sampling. 2. Systematic sampling. 3. Convenience sampling. 4. Stratified sampling. 5. Quota sampling. Each method has advantages and disadvantages depending on the situation. We will now take a closer look at each one. Sampling method 1. Simple random sampling. In this method, a sample is formed by selecting members from the population at random, where each member of the population has an equally likely chance of being selected. In simple cases, a sample could be created by drawing names from a hat. For most samples, though, it is more common to use a random number generator. The sample is random in order to stop bias. Example 1. Sam wants to randomly select 5 people to use in a sample from a population of 20. He begins by assigning each person in the population a number from 1 to 20. Using the random number generator on his calculator, he then generates 5 random numbers between 0 and 1, 0.532, 0.805, 0.686, 0.774, and 0.272. Help Sam by converting these numbers to numbers between 1 and 20, so he can use them to select members from his sample. To get random numbers between 1 and 20, we multiply each number by 20 and round up to the next whole number. So for the first one, we would do 0.532 times 20, which equals 10.64. So we would round that to 11. Repeating this for the remaining values gives us 5 random numbers between 1 and 20. We would get 11, 17, 14, 16, and 6. Anyone who was assigned these numbers in the population would be selected from the sample. Please note, in this case, we wanted 5 unique random numbers. If our calculator generated 2 numbers that were similar, we could end up with the same value when converted to a number between 1 and 20. In this situation, we would keep generating additional random numbers until we had 5 that were unique. Sampling technique 2, systematic sampling. In this method, a sample is formed by choosing a random starting point, then selecting members from the population at regular intervals, i.e. every 5th member, or 10th member, or 20th member. In other words, it uses a system for selection. This method is often favoured by manufacturers for sampling products on a production line. While systematic sampling is better than a simple random sample, it can still under or over-represent a subgroup within the population. Look at the picture. This is how the sample is taken. Every third member in the population is taken to produce a sample. Example 2. A machine produces 400 items a day. At what interval should an item be selected in order to obtain a systematic sample of 25 items? Well, the interval required is equal to the population size divided by the sample size, which in this case is equal to 400 divided by 25, which is equal to 16. So every 16 items should be selected. Sampling technique 3, convenience sampling. In this method, a sample is formed by members of the population who are located conveniently to the interviewer. For example, if surveying people at a shopping centre, convenience sampling would be asking only the people who walk past and look interested in stopping to answer questions. A disadvantage of this type of sampling is that it is unlikely to be truly representative of the wider population. Sampling technique 4, stratified sampling. In this method, a sample is formed by selecting equal proportions of each subgroup or strata within a population. This is particularly appropriate when there are clearly defined subgroups and each one requires adequate representation. For example, if a survey was being conducted on the student population of a school and it was important to represent all year levels, a sample might be formed by randomly selecting 10% of students from each year group. While stratified sampling can be more expensive and time-consuming than other methods, it can also provide the best representation of a wider population. Example 3. Martha wants to use a stratified sample of 50 members to survey her school's population. If there are 70 teachers and 1,100 students at the school, 1. How many teachers should be in the sample? 2. How many students should there be in the sample? Well, the first thing we need to do is find the total population. Well, the total population is equal to 1,100 students plus 70 teachers, which is 1,170. So, 1. The teachers, well, we want the same proportion, so therefore it is equal to 70 out of 1170 times the 50, which was equal to 2.991, which is equal to 3 teachers. Number 2, students. Again, we want exactly the same proportion, so that is equal to 1,100 out of 1170 times the 50, which is equal to 47.008, which is equal to 47 students. So we want 3 teachers and 47 students, which will give us 50 members in the stratified sample. Sampling technique 5, quota sampling. Quota sampling is a non-random method of sampling which is similar to stratified sampling. The researchers determine how many of each strata are required to be in the sample and then fill this quota, often using convenience sampling. Once the quota for a particular strata is filled, any respondents from that strata are then disregarded. For example, if researchers are interested in movie preferences for various age groups, they may have their first question being, "What is your age?" If the person then states an age group that has already had its quota filled, no more questions are asked for the person. This makes quota sampling a fairly time-efficient method of sampling. Let's do a couple of questions. Question 1. A school principal wants to estimate the number of students who ride a bicycle to school. Which 2 samples should he use to not introduce bias? A. All students who are in the school band. B. 8 students in the hallway. C. 10 students from each grade, chosen at random. Or D. 130 students during the lunch period. To gain a good representation of the school, the number of people in the sample should not be too small. It should also be such that they are chosen in a randomized way as possible. So the 2 good answers here are C and D. Question 2. Out of 2,160 students in a school, 216 were chosen at random and asked their favourite colour out of red, blue and yellow, with 99 choosing red, 63 blue and 54 yellow. A. 1 in every how many students at the school were sampled? B. Estimate the number of students in the whole school who prefer the colour red. C. Estimate the total number of students in the whole school who prefer the colour blue. D. Estimate the total number of students in the whole school who prefer the colour yellow. A. Divide the total number of students at the school by the number of students that were asked their favourite colour. So therefore we get 2160 divided by 216, which equals 10. So 1 in 10 students were asked. B. Assume that the sample was a fair representation of the school, i.e. the rest of the school would have chosen red as their favourite colour in the same proportion. We know that 1 in every 10 students were sampled, meaning the school is 10 times as big as the sample. Therefore, the number who prefer red is 99 times 10, which is 990. C, in the same way, 63 times 10 is equal to 630. They prefer blue. And D, in exactly the same way, 54 times 10 is equal to 540, prefer yellow. The most important thing when sampling is that you make it as fair and possibly as random as possible so that your sample is not biased and represents the population as a whole.